comparison between the ideal and the non-ideal solutions. I might have given you only 3 points. So first basic point I might have given to you, what are ideal solutions and what are non-ideal solutions in terms of the Raoult's law. And then I might have given you 2 other points in terms of the delta H mixing and the delta
V
H
mix.
mixing and
Delta V mix.
Good morning, sir.
Morning, better.
Good morning, sir.
Morning, better. Delta H mixing and delta V mixing. These are the only points I have given to you now.
Yes, sir.
And now
Yes,
I'll go
sir.
for the continuation. Someone want to ask anything?
No, sir.
Anyone want to ask better? Nothing? Chalo. I'll go for the class continuation. But before the class, yes, before the class, once cross-check it, I am having dreaded fear of the juniors. Because juniors are creating a fear in my mind.
Recording in progress.
Because juniors are creating fear in my mind.
Recording stopped.
Just check any juniors are there. Roll starting from number 21.
No, sir.
Starting from number 21.
Not there, sir.
Not there? It's okay. Now, this one thing definitely it'll haunt me. It'll haunt me throughout my teaching career. It'll haunt me throughout my teaching career that to most of you I have not observed. To most of you I have not observed. Yes. All of you are not there in the physical classes when we have conducted the classes in the month of the February or the March, some classes we conducted, all of you are not there. So definitely it will haunt me because in the future after 10 years or 15 years, we are meeting on the road. You are able to recognize me that I am Sanjay Singh. How shall I recognize you? You will know he's my Sanjay sir. And you'll come towards me with a laughing. You'll come towards me with a laughing, with a smile. You come towards me. And definitely when you will come towards me in a smiling way, and I'll be standing in a stone faced in this way, I won't get the idea why this man or the woman is coming towards me in the smiling way. Who are they? And you will tell me, hi sir, hello sir, good morning sir, how are you? I am so and so, I am so and so. But I can't frame out. I can't figure out. So I'm praying for the God, this corona should go. So at least from the month of the July, if not July, from August, at least if not August, from September, if not September, after Dashera Yar, at least from October onwards, we all should come to the college and we should know each other. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, it is required. Yeah. Otherwise, friends are not knowing who are they. Only name you are knowing. He is X, Y, Z, or she is A, B, C, D. But we are not knowing physically who are they. And definitely it is not good in the teaching. That teaching is going on, class is going on, but we are not knowing who are the other people are there. This corona has to go. At least the corona has to go for our benefit, our happiness. Now coming for the continuation. Now I go for the point number 4, and definitely here I am going for the ideal, and then here I am going for the same non-ideal, and this non-ideal I am dividing into 2 parts, and that is nothing but it is positive deviation, it is there, and the negative deviation, it is there. Positive deviation and the negative deviation, it is there. So this I am dividing into the positive and the negative, it is there. Now I'll go for the 4th point and the 5th point. 4th and the 5th, no? 4th and the 5th both are star point. If I am going for ideal, delta S mixing is positive. In positive also, delta S mixing is a positive. Hey, even in a negative also, delta XS mixing is a what? Positive, it is there. Now I'll go for the ideal. So once I'm going for the ideal, here I'll go for the delta G mixing. Delta G mixing is a negative. Here also
Less than 0.
mixing is negative. Here also delta G mixing is negative, and that is the reason why at this point I have told you that it is and what a star mark point it is there. Ideal, positive deviation, negative deviation, everywhere delta S mixing is a positive. Ideal, positive deviation, negative deviation, everywhere delta G mixing is a what negative. Let us now go for understanding. What is delta G? Delta G is giving information regarding spontaneity. So formation of a solution may be ideal solution, or maybe non-ideal solution occurs by itself. Maybe ideal solutions or non-ideal solutions formation occurs by itself without the help of any external agency or any external support. Means the formation of the solution is spontaneous. Maybe ideal solution, maybe non-ideal solution. So if the formation of the solution is spontaneous, and for the spontaneous condition, delta G is the what negative, and therefore in all the three I am mentioning a negative condition. Coming for delta S you know very well, it is called as a change in entropy, and change in entropy is not at all bothered regarding ideal or non-ideal. From thermodynamics you know very well that entropy is a measure of only a measure of degree of disorderedness and randomness of the system. Only entropy is bothered regarding disorderedness. Whether it is an ideal solution, non-ideal positive, or non-ideal negative. How you are making solution, component A and component B, both the components you are mixing. Why both the component? One component is a solute, one component is a solvent, then only they are called as a solution. When you are mixing the two components, the number of the particles are remaining same, the number of particles are increasing.
Increasing.
Number of particles are increasing. When number of particles increases, randomness increases. So when randomness increases, delta S is becoming what? Positive. So whether it is an ideal solution or a non-ideal solution, delta S mixing is a what? Positive it is there. Anyone doubt in these 2 points?
No, sir.
No, sir.
At this point, I am rubbing it. Shall I?
Yes, sir.
I love it. And now I'll go for the point number 6. Point number 6 is the formula point, which already I have given to you. PT is equal to PA plus PB. Total pressure is exactly equal to the sum of the partial pressure of the individual components A and B, and this condition is an ideal condition. Coming for positive deviation, P total is greater than sum of PA plus PB. So from this, it's very clear that whenever we are going for positive deviation, in positive deviation, pressure we are getting more than expected, less than expected.
More than expected.
More than expected.
More than expected.
Therefore, here I have mentioned in this case equal to expected. This is equal to, this is expected. Here it is, this is expected. This is more than expected. In negative deviation, total pressure, whatever we are getting, it is less than expected. It is there. This is there. This is exactly correct. This I can write in the other form also. Other form is the form which I have taught you in this way. This PT, it is there. I can write as in P naught XA plus I can write as in P naught XB. It is there. This I can write as a PT is greater than P naught XA plus it is P naught XB. It is there. In this case, I can write PT is less than P naught AXA plus P naught BXB. It is there. Anyone doubting point number 6?
No, sir.
Now I'll go for the point number 7. Point number 7 is the explanation. Point number 7 is the explanation of the point number 6. Why here the pressure is as expected? Why here pressure is more than expected? Why here pressure is less than expected? This explanation we will go from the point number 7. So A, B, and AB interactions are nearly same. Interactions are nearly same. If you are assuming A as a solute and B as a solvent, so solute interaction, solvent interaction, solute and the solvent interaction, solute interaction, solvent interaction, solute interactions, they are nearly same. So when all the three interactions are nearly same, solute, solvent, and the solute and the solvent, and that is the reason why whatever the pressure we are expecting, we are getting same pressure. Now coming for here. In this case, I'll say that AB interaction is weaker. What is meaning of AB? Solute solvent interaction is weaker. As a solute solvent interaction is weaker, that is the reason why solution easily undergoes evaporation. Solution easily undergoes evaporation, and more vapors are accumulated in comparison to that of the what expected. So AB interaction is weaker than AA and BB interactions. AA and BB interactions. In this case, vapor pressure is less than expected. So therefore, in this case, AB interaction is stronger than AA and BB interactions. So here all the three interactions are same. Here AB interaction is weaker and here AB interaction is stronger. Towards blackboard, stop writing. Here AB interaction is weaker and therefore here escape tendency is more. More is the escape tendency, more is the evaporation. More is the evaporation, more is the vapors accumulated. More is the vapors accumulated, more is the vapor pressure. Coming for here. Here AB interaction is a stronger. So when AB interaction, the bond is a stronger, bond easily won't break. And bond easily won't break, liquid easily can't transform into vapor. So therefore, escape tendency is less. When escape tendency is less, vapors accumulated is less, and therefore vapor pressure is also what less than expected it is there. Or
Yes.
okay. One topic. Okay. All of you?
Yes, sir.
Now. Now, if you observe, if you observe, here I have mentioned that here escape tendency is more. Here I have mentioned that escape tendency is what less it is there. Now question arises, why here all the interactions are same? Why here interactions are different? Why interactions are different? Because of the identical shape, size. What identical shape and size? Solute and the solvent, they are having identical shape, it is there, size it is there, and character it is there. Here interactions are different. Here AB interaction is weaker, and here AB interaction is stronger. So I'll go for the 8th point as a common point. What is common point? Different shape, size, and character. Different shape, size, and character. So here all the three interactions are the same. What three interactions? AA interaction, BB interaction, and the AB interaction. Here AB interaction is weaker. Here AB interaction is stronger. Why here weaker? Why here stronger? Because they are differing in shape, size, and the character. I'm talking regarding whom? Different shape and size. I'm talking regarding solute and solvent, A and B, not anything. Solute and the solvent, they are having different shape, different size, and different character. Here the solute and the solvent are having identical shape, size, and the character. Clear up this one?
Yes, sir.
Now I'll go for the 9th point. 9th point, I'll go for a graph. 9th point is a graph point. It is there. I'll go for a graph. In the examination, they'll give you graph, and from the graph, they'll ask you, it is what solution? It is an ideal solution or non-ideal solution with a positive deviation or non-ideal solution with a negative deviation. It is what? So simple graph it is there. Simple graph it is there. Now, first you understand one graph properly. Then only draw. Don't draw it in the starting only. Now, definitely here I'll go for the pressure. Here I'll go for the what pressure it is there. Vapor pressure, you say pressure, or you say precisely you say vapor pressure, so that confusion won't be there. And here you say mole fraction. You say mole fraction. Two components are there, component A and the B, it is there. Let us assume here XA is equal to 1. So at this point, XA is equal to 1. XA is equal to 1 means, can I say it?
XB is 0.
Once I'm saying XA is equal to 1, can I say I'm talking regarding pure A?
Yes, sir.
Yes, sir. XB will be 0.
Then definitely here XB is equal to 0. So if I am choosing as an XA 1, so therefore here I'll choose as an XB is equal to 1. So this is the corner where we are having pure B, it is there, and no A, it is.
Pure B.
So here we are having pure A, here we are having pure B, in between we are having solution. So pure A it is there, pure B it is there, in between we are having solution, it is there. And yesterday, if you observe from the Raoult's law, the graph I have given to you starting from the origin, and here I have given you P naught. Given you P naught?
Yes, sir.
Given
Yes,
you P
sir.
naught. Now exactly means exactly same type of the graph I'll draw. Now, exactly means exactly same type of the graph I'll draw. Same type of the graph I'll draw. Here, suppose take example, I'm making this as a P naught A. It is A, so therefore P naught A. And let us assume here I'll go for the
P naught B.
B. I'm going for the P naught B. So this is straight line. This straight line is nothing but it is our ideal. Don't copy it. This is nothing but our ideal solution. So if a straight line it is there, it is nothing but whatever ideal solution graph it is there. This graph indicates A component and the B component both are having same volatility. Both are having same volatility. Therefore, check P naught A value and the P naught B value is exactly same. It is there. Sometime what they will do, they'll give in this way. They'll give in this way. This they will give as in P naught B. If this they are giving P naught B, still it is a straight line and still it is the graph for the what? Ideal solution only. But here difference is what? B is more volatile than that of the A. Can I say?
Yes, sir.
Yes.
Yes.
In the previous case, I have put both line exactly same place, and now here I am putting in this way. Maybe in the some books, they will give in this way. They'll give in this way. This as in P not B. Check the straight line. But in this case, volatility of the A is more than that of the B. So you are not bothered whether this line is a straight line, this line is this way, or line this way. We're simply observing it is a straight line or not. If it is a straight line, it is there. It is a proper ideal condition. It is there. If this is a completely straight line, it indicates volatility of both the components are same. If it is of this type, means volatility of this component is more, this component is less. If it is this type, volatility of this component is more and this component is what? Less. It is there. Clear all of you?
Yes, sir.
Yeah.
It's because here 3, here 3, here 3, 6 diagrams I can't draw. Therefore, first I have given you what? Understanding part I have given to you. And now just one diagram I choose. Only means one diagram I go for. So now first I go for the vapor pressure, mole fraction. XA is equal to 1, XB is equal to 0, XB is equal to 1, XA is equal to 0. This I am choosing as a P naught A, and this I am choosing as a P naught B. So therefore, in this case, I am choosing that A is a more volatile than that of the B, and this is nothing but called as an ideal solution graph. It is there, straight line. Now I am going for the another one. And once I am going for the another one, it is there. Another one, it is there. Same thing, vapor pressure. Same thing, mole fraction. XA is equal to 1, XB is equal to 0, XB is equal to 1, XA is equal to 0. Same thing. Same thing. This is a P naught A. Same thing. This is a P naught B. Just for convenience, just for comparison, first I'll draw the ideal graph. Ideal graph, I am making it dotted line. So whatever this graph and this graph you see, first I am making the ideal graph by dotted line. Yes, this is our ideal graph. It is there. Now for comparison, now I go for the positive deviation. Positive deviation means more than expected. This was expected line, dotted line. This was a dotted line expected. This is more than expected. No, sir, why you are going for more than? Clearly, I told you in the positive deviation, vapor pressure will be what? More than expected. So crest formation is more than expected and trough formation is what? Less than expected. And that is the reason why here I am going for the crest formation. Here also I am going for the crest formation. Here also I am going for the crest formation. So check, it is more than, it is straight line. More than normal, more than normal, more than normal. Therefore, it is called as a what? Positive deviation. It is. If I am going for the negative deviation graph, don't draw here and there. This drawing in the positive column only. This draw in the negative column only. Don't draw here and there. So if I am going for the same thing, Go on copying. So here also for comparison, first I am drawing the dotted line. Dotted line is nothing but our ideal graph, it is there. And now here I'll go for the, here I have gone for the crest formation. Here I'll go for the trough formation. Less than expected, less than expected, less than expected. And this is nothing but our negative deviation. So this you draw in the ideal solution, this in the positive column, this in the negative column. Once it is copied, let me know. Good.
Thanks.
Anyone doubt in this? Shall rub this one?
So 1 minute, sir.
Okay, beta.
Done, sir.
Good. Now this I'm rubbing it. This was point number 9.
Yes, sir.
Now I'll leave some point, and that point is not a column point. That you are not writing in a column. That you are not writing in a column. No, sir, already we have made a column. Now we can't rub the column. Who is saying rub the column? I never told rub the column. I never told rub the column. Just write in a straight line by giving hashtag marking. By giving hashtag marking straight. And clearly I'm mentioning whatever I'm giving to you, it is not a column point. It is not for the ideal, not for the non-ideal. I'm giving you understanding point. After understanding point, then I'll go for the column points. So right in a straight line, understanding point. And that is side heading azeotropic pressures. Side heading azeotropic pressures. side heading azeotropic mixtures. Azeotropic mixtures, right? A binary mixture, a binary mixture, a binary mixture, a binary mixture. In the slide, point number A. Point number A. A binary mixture which cannot be resolved. A binary mixture which cannot be resolved. Resolved means in the bracket right separated. A binary mixture which cannot be resolved in the bracket right separated into constituent components, into constituent components, into constituent components, into constituent components by distillation, by distillation, by distillation, by distillation are called azeotropes. By distillation are called azeotropes. Are called azeotropes. Are called azeotropes. Point number B. Point number B. Point number B. Point number B. They are also called constant boiling point mixtures. They are also called constant boiling point mixtures. They are also called constant boiling point mixtures. Constant boiling point mixtures. And having fixed composition. And having fixed composition. And having fixed composition. And having fixed composition at that boiling point. And having fixed composition at that boiling point. And having fixed composition at that boiling point. Fixed composition at that boiling point. Definition. Definition I have given to you. A binary mixture. Azeotropic mixtures are the water binary mixtures which cannot be resolved in the bracket separated into constituent components by distillation are called azeotropes. Now, whatever the B point it is there, B point you will understand by C point, and now I'll give you C point. C point I will take example, a rectified spirit. A rectified spirit. Rectified spirit is nothing but it is ethyl alcohol plus water. It is ethyl alcohol plus water. Hey, I have not mentioned anything. I have mentioned rectified spirit. If simply I am saying ethyl alcohol and water, ethyl alcohol and water you can separate. If here I am not mentioning rectified spirit, ethyl alcohol and water you can separate. Ethyl alcohol boiling point is 71.1 degrees Celsius. Water boiling point is 100 degrees Celsius. Better write in the proper way for understanding. Ethyl alcohol boiling point is 78.1 degrees Celsius and water boiling point is 100 degrees Celsius. Separated, can be separated for understanding and writing. Can be separated by distillation. Strictly speaking, I am saying fractional distillation. FD means fractional distillation. You write full form fractional distillation. So yes, ethyl alcohol and water, they can be separated by fractional distillation. Can anyone tell me why? They are differing in their boiling points. They are differing in their boiling points. Boiling point, they are differing in their boiling point. If a boiling point difference is even less than 10 Kelvin, if the boiling point difference is even less than 10 Kelvin also, we can separate them. We can separate them by help of the water, fractional distillation, and here boiling point is definitely more than 10 Kelvin it is there. Easily you can separate them by help of the water, fractional distillation. Now I am going for the rectified spirit. Now you will go for the proper understanding. Rectified spirit. Once I am saying rectified spirit, here also we are having ethyl alcohol is there and the water it is there. But here boiling point is a 78.15 degrees Celsius, 78.15 degrees Celsius. Both the boiling points are same or different? Same. That is the reason why I have used the word in point number B, constant boiling point mixture. Constant boiling point mixture means I want to say that boiling point of both the components are same. As boiling point of both the components, as the boiling points of both the components are same, therefore they can't be separated by fractional distillation. They can't be separated by fractional distillation because they are having same boiling point or the constant boiling point it is there. Clearly in the B point I have mentioned to you, at this boiling point, their composition is fixed. At this boiling point, their composition is fixed. So once you are talking regarding rectified spirit, in rectified spirit, always water is a 4.4% by weight. Always means always water is a 4.4% by weight it is there, and ethyl alcohol is always 95.6% by weight it is there. This is the meaning of a constant boiling point, and at that constant boiling point, at this constant boiling point, composition is fixed. So in rectified spirit, it is 4.4 only, it is 95.6 only it is there. And this example, why I am giving to you, it is given in the NCERT book, given in the syllabus, organic chemistry, you will read this one. Whenever Malardi sir will teach you ethyl alcohol, there you will read. Once it is copied, let me know.
So,
Done? Okay. Now I'll go for the same type. Whatever now example I am giving to you, that you have read in topic 5th A group family. So therefore I told you nothing I am taking example from outside. Nitric acid it is there and water it is there. Nitric acid and the water both are having different boiling point it is there. But when nitric acid and the water, if nitric acid and the water, they are forming azeotrope. If nitric acid and the water, they are forming azeotrope. Both are having same boiling point, 393.5 Kelvin, 393.5 Kelvin. So as the boiling point of the both the components are same, therefore they can't be separated by help of the water, fractional distillation. So again, they can't be separated. Hey, boiling point of nitric acid and boiling point of water is different. But when they are forming azeotrope, then they will have the water, same boiling point is there. And at this boiling point, composition is 68% by weight and water is 32% by weight it is there. In the examination, local examination, final examination, they're asking you boiling point. In the previous case, 78.15 degrees Celsius. This deliberately I'm writing in the Kelvin, 393.5 Kelvin. There, ethyl alcohol was how much? 95.6. Water how much? 4.4. Here, water how much? 32. Nitric acid how much? 68. Make it. So these two examples, ethyl alcohol and water, and nitric acid and the water, they are there in our syllabus. 5th A, it is there. Organic chemistry, it is there. this chapter, solutions and colligative property, it is there. Once it is copied, let me know.
Done.
Good. Good. Now coming for our actual point. This I have given you only for understanding. Now coming for the actual point. Actual point is a 10th point.
Yes, sir.
Now 10th point. Actual point is the 10th point. Coming under ideal solutions, it does not form azeotropes. 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 Therefore, the components can be separated by distillation. Therefore, the components can be separated by distillation. Therefore, the components can be separated by distillation. So in ideal solution, components can be separated, cannot be separated.
Can be separated.
Can be separated by help of what?
Distillation.
By help of distillation. Now coming for the positive deviation. It forms minimum boiling point azeotropes. It forms minimum boiling point azeotropes. Minimum boiling point azeotropes. Under negative, it forms maximum boiling point azeotropes. Minimum boiling point azeotropes. Maximum boiling point azeotropes. Maximum boiling point azeotropes. Why here I am giving minimum? Why here I am giving maximum? Because the point which I have taught you long back, boiling point and the vapor pressure is inversely proportional. In positive deviation, vapor pressure is more than expected. When vapor pressure is more than expected, boiling point will be less than expected. Less than expected, therefore called as a minimum boiling point. Negative deviation. In negative deviation, vapor pressure is less. Lesser is the vapor pressure, higher is the boiling point, and therefore here I have used the word as a what? Maximum boiling point azeotropes. Maximum boiling point azeotropes. Last point, point number 11, and that is nothing but examples. Examples. 4, 4, 5, 5 examples I'll give to you. You write in the words or write in the formula. Purely your wish it is there. For me, problem it is not there. Now come under, write under ideal solutions. Ideal solutions. Shall I start?
Yes, sir.
Dilute solutions. Next, benzene plus toluene. Don't write separately. Benzene plus toluene. Two components you have to write. Component A and component B to form solution. It's not benzene. Benzene plus toluene is example. Benzene plus toluene, comma. Third example. N-hexane plus N-heptane. N-hexane. Hexane hexane and N-heptane. N means normal. Normal means a straight chain. N-hexane plus N-heptane. Fourth example, chlorobenzene plus bromobenzene. Chlorobenzene plus bromobenzene. Chlorobenzene plus bromobenzene. New example, ethyl bromide plus ethyl iodide. Ethyl C2H5. Ethyl bromide plus ethyl iodide. ethyl bromide plus ethyl iodide. Last example, N-butyl chloride plus N-butyl bromide. N-butyl chloride plus N-butyl bromide plus N-butyl bromide. Done?
Yes, sir.
Whatever the examples I have given to you, except dilute solutions, observe benzene and the toluene, hexane and the heptane, chlorobenzene and the bromobenzene, ethyl bromide, ethyl iodide, N-butyl chloride, N-butyl bromide. What you are observing in them? What you are observing in them?
They're all substituted benzene.
No, not organic. They are having identical shape, or they are having identical size, or they are having identical character, or maybe all three. Maybe they are having same shape, maybe they are having same size, or maybe they are having same character, or maybe all three. Because long back I have given to you under ideal solutions. Under ideal solutions, whatever the components are there, A and the B, they should have the same shape, same size, and the same character. So therefore, these examples I have given to you now come under the positive deviation. Because if the same characters will be there, same size will be there, then only AA interaction, BB interaction, and AB interaction will be what? Same. Now I am going for positive deviation. In positive deviation, I can't choose any example. In positive deviation, I'll choose only those examples in which AB interaction is weaker, means the solute-solvent interaction is weaker than that of the solute-solute and solvent-solvent. Right. Examples under positive deviation. Ethyl alcohol plus N-hexane. Ethyl alcohol plus N-hexane makes star mark. Why star mark? It is given in the NCERT book. Ethyl alcohol plus N-hexane star mark. Second example, ethyl alcohol plus water. Ethyl alcohol plus water star mark. It is again given in the NCERT book. Other examples, whatever I am giving to you, it is not given in the NCERT book, but coming in NEET examination. Coming in the NEET examination, right? From third example onwards, acetone plus ethyl alcohol. Acetone plus ethyl alcohol. New example, acetone plus carbon disulfide, CS2 carbon disulfide, acetone plus carbon disulfide. New example, methyl alcohol plus water, methyl alcohol plus water. New example, acetone plus benzene, acetone plus benzene. Last example, chloroform plus carbon tetrachloride. Chloroform is CHCl3. Carbon tetrachloride is CCl4. Chloroform plus carbon tetrachloride. Examples over.
Sir, once can you repeat the second example, sir?
Second example, which means second example means I have given to you ethyl alcohol and the water. First, I have given to you ethyl alcohol and the N-hexane. Second, I have given to you ethyl alcohol and the water.
Thank you, sir.
Now coming for the negative deviation. Negative deviation. Acetone plus chloroform. Acetone plus chloroform, star mark. Why star mark? It is given in the NCERT book, therefore star mark. Acetone plus chloroform. Nitric acid plus water. Nitric acid plus water, star mark. Nitric acid plus water. Rest of the examples not given in the NCERT book, but they're in the NEET examination, right? From third example onwards. Acetone plus aniline. Acetone plus aniline. Chloroform plus diethyl ether. Chloroform plus diethyl ether. HCl plus water. HCl plus water. Chloroform plus benzene. Chloroform plus benzene. Chloroform plus benzene, etc. In all the three cases, etc. So, why examples I have classified in such a way, depending upon the nature. What is the first condition? In first condition, they should have identical shape, size, and the character. In the other two conditions, I have taken such a pair where A and B interaction is weaker or A and B interaction is stronger. If suppose take example, I am going for the positive deviation. In the positive deviation, first example I have taken ethyl alcohol and the hexane. Means hexane bond, ethyl alcohol bond is a stronger than that of the ethyl alcohol and the hexane bond. Means I am saying that ethyl alcohol and the hexane bond is weaker because long back I have mentioned to you in positive deviation, AB bond is weaker than AA bond and the BB bond. Then if you come to the negative deviation, in negative deviation, I have given you example. First, take simple example, chloroform and the acetone. In the chloroform and the chloroform and the acetone bond is a stronger than chloroform bond and the acetone bond. So AB bond is a stronger, and that is the reason why it is the example of the negative deviation. Whatever the table in that 11 points I have given to you, all of you have a look first. All the 11 points. Still time is 4 minutes. 4 minutes is an ample time to have a look. Have a look at all the 11 points so that it will be easy for you to remember and understand. Class strength is very less, but 62. Yesterday there was something 75, 76 were there. Unless until you are not maintaining strength properly, absent for 1 day also, you check in the 1 day how much information I have given to you. If you are absent for 1 day also, then a lot of information you are losing, and then you will face difficulty in that topic. It's not a school. In the school, you will have class maximum 45 minutes. In that, teacher will 10 minutes come 10 minutes late. 5 minutes she will take attendance. 10 minutes she will shout on you. 10 minutes she will check homework. 15 minutes she will teach us. But in the private college like Chaitanya and the Narayana, if classes of the 1 hour, 45 minutes solid will teach you. 45 minutes solid teaching means a lot of information will give to you. It's over, beta. Let us meet tomorrow at same time. See you. Thank you.
Thank you, sir. Bye, sir.
Bye, sir.
Beta, bye. Thank you.
Thank you.